Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore how to perform text classification using pgvector and vector embedding. So already in our previous video we discussed in detail how to use vector database for text classification or image classification. If you want to know that detailed explanation, you can check the link given in the description box in the prerequisite section. So the simple idea is basically we'll be having our training dataset. Suppose in a particular column we are having text and in another column we are having the classes or labels for that particular text. Okay. Now what we will do as a first step, we will take all those text from the training dataset and we will convert to the embedding vector. That is, we will be getting its vector representation using Titan multimodal embedding or Titan text embedding or any other LLM embedding model. And then we will be storing those vectors along with their respective classes or labels in a vector database. Okay, that is the first step. And then if we want to classify any unknown text and map it to a particular level, what we need to do? First, for that particular unknown text, we need to get its vector representation using embedding, and then we will search in our vector database which training data is having most similarity with that particular unknown text vector. And whatever label that particular most similar training vector will be having, that we can consider as the label or class for this unknown test vector as well, because they are most similar and we know the class for the training data. So we can simply say that the same class will be having for this test data as well, right? So on this I have already created two detailed projects, and that link I will be sharing in the description box. You can go through that, try to play with it. That way you will be becoming very comfortable in text or image classification using embedding. Now we will be applying that particular concept in BBC News classification. So here we will be getting some training data and test data. If you go to the data tab, here I can click on training dataset, and here first we need to join the competition, and I will understand and accept it. And here if I scroll below, the training dataset looks like this. So where we are having article ID and text from that article is available here, and then it is basically classifying whether it is business category document or sports category or tech category, etc, etc. We are having various categories. Now based on that we will be given some test dataset as well, for which only article ID and the text content will be available, and we need to determine in which category these kind of news are actually belonging to. For example, this particular news can be belonging to tech or business category or sports category, etc, etc. That we need to derive and upload the result set. Okay, and the result set what we need to upload in this competition should look like this. We need to only put article ID and the category. So in this test data we are having article ID as well as text. Text we no need to upload when we will submit our result. Only the article ID and in particular news is getting mapped based on our training model that we need to provide as depicted in this sample solution. Okay, right? So I hope you are getting it what we need to do. So as the first step what I will do, I will download all the dataset. Like here we'll be having our training data, test data and sample solution. Okay, let it get downloaded, and here what I will do, I'll be using my Google Colab notebook. So here as a first step I'll be uploading that particular dataset in this Google Colab local file system. So here in the download section, this is the file. I'll be uploading this zip file here. I'll click on OK. So here you can see the file is getting uploaded. Cool. Now let me show you how we can perform embedding and store those embedding vectors in PostgreSQL database using pgvector extension. Okay. So for that, if you go through this particular GitHub repo of pgvector, they have mentioned a beautiful sample code to do the same activity. So I'll just zoom this little bit. So to perform embedding, maybe we can use Titan text embedding model or Titan multimodal embedding model, etc, etc from AWS Bedrock. But in this video we are not going to use AWS Bedrock, but rather I'll be showing you how to perform embedding using some open source models. Okay, and in this demo I'll be using this sentence transformer all mini LM L6 v2, this particular model. And here if you see, this is a sentence transformer model. It maps sentence and paragraphs to a 386 dimensional dense vector space, which can be used for tasks like clustering or semantic search, etc, etc. So in our this particular text classification use case, it is nothing but kind of clustering use case only, right? Because already we'll be having our training dataset and its mapping. So training vector and its mapping are already available in PostgreSQL using pgvector, and we need to find out our unknown test vector is having highest similarity with which training vector, right? And based on that training vectors class, we can conclude that this particular test vector is having same class as of most similar training vectors class, right? So kind of clustering classification use case. So not a problem to use this particular model to get the vector representation of the news, okay? And even in this particular example also, they have used the same model, that is sentence transformer. First we need to import this here from sentence transformer, import sentence transformer, and then we can basically define our model, the model what we have decided to use, and then we can pass our input to get the embedding result, right? And then using a simple insert into command, we can store those embedding vectors in our PostgreSQL database, okay? Right? So I hope this particular flow you understood. So that same concept we are going to implement here. So as a first step here, you can see this particular zip file is uploaded. I can unzip this. So unzip, and then here I'll be copying this path and paste that. So here, if I refresh our Google Colab file system, now we are having 3 CSV files. One is sample solution, how we should be uploading. This is not that much useful. We are having our test data, we are having our training data. Now here as a first step, what we'll be doing, we'll be installing 3 different modules. One is sentence transformer, for embedding it is needed, Pandarallel to perform embedding in parallel manner, and this particular module is required to execute insert query or select query in PostgreSQL database. Okay, right? So I'll be doing this pip install, let it get downloaded, and by that time parallelly I'll be creating a RDS Postgre instance in our AWS. Okay. So here I can go to database and create database. And here I can select PostgreSQL. Engine version, we can choose the default one. Scroll below. Here this is a free tier one, experimentation purpose we are using. Database identifier, that is fine. Master username, that is fine. Master password. So here in our earlier video also we have used this particular password. I'll be using that same. Here you can see this is a strong password, and I will confirm the master password also by putting that same password. And then here T3 micro is fine. Storage you can keep as it is. Auto scaling is not needed. And then here default VPC we can keep. Publicly accessible yes. And here security group we can keep default one. Database port 5432 is fine. Password authentication, it is fine. Monitoring not needed. Additional configuration. Here database name we need to provide. So let's consider the database name we are putting test Kaggle. So I'll put that. And parameter group backup is not needed. Encryption not needed as of now because just doing POC. Auto miner version update not needed. And here we can create the database. Okay, right? So let the database get created. And till then we'll go back to our notebook. And here you can see that all these modules got installed. Now we can import all of them, pandas, to read our training dataset and perform embedding. And we'll be using sentence transformer to refer our model. And here this particular model will be using to interact with Python and PostgreSQL. Okay, right? So here in this particular line, it is going to take some time to import this because these models are very huge, large language models. So we need to wait a little bit till it get completed, and here it is done. Now here DB host, DB username, password and port, these informations we need to provide. So username already we know, that is this one, and password is this one. I'll be putting that. In our production system, we should not be putting user ID password as hard-coded value, but rather we should be taking from AWS Secret Manager or some config file. So here, because this is just a POC, I am directly hard-coding. And here we are using that Postgre wrapper .connect, and here we are providing all this required information to connect with our PostgreSQL database, which we have just now launched. Okay, so here you can see it is in creating phase. Let's wait for some time. And here connection timeout 10 seconds we have provided. Okay, right? And auto commit true. So whatever insert query will be executing, that will be automatically committed. We no need to explicitly call .commit to commit it. And database name. So here in our this case, the database name is test Kaggle. So we'll be putting that. Okay, right. So this way we can set up the connection between PostgreSQL and our Python. And then here we are basically importing this particular model from sentence transformer for embedding purpose. Again, it is going to take some time. Here you can see all the necessary downloads it has done. And then here we are going to read this training dataset, which basically contain the article ID, some text which is related to that particular news, and the category. Like this particular text is business category, and so on and so forth. Okay, right? So here I will be basically reading that particular training data. If I do dot head, here you will be getting a view of that data set. And now to perform embedding, here I have written a simple function based on this particular sample example. So here what we are doing, model.encode, and we are passing our input text. Same format we have done. We are passing the query as input for our this function, and we are calling model.encode to get the embedding result for this input text. Okay, so I'll execute that. For example, here I have basically given a dummy example that generate embedding hello there. Hello there is suppose our text or news, and if we call our generate embedding, here we will be getting a vector. Okay, or we can say it is nothing but a numpy array of float category, right? So here if I do type of ms, there you will see that it is nothing but a numpy ld array, right? So this way we can perform embedding, and also I can show you the length of it. So it is 384. So in short we can say that this particular model convert any input text to 384 dimensional vector space. Okay, and the same thing we have encountered in this documentation also, that it maps sentence and paragraphs with 384 dimensional dense vector space, right? So these conclusions are matching. This one just I have kept for exploration purpose, not really needed in our this particular text classification use case. Okay, now here what we need to do as a next step, for all this text we need to get their vector representation by calling this model. So we can easily call dot apply to apply this particular function on this text column. But here if you see, this conversion process from text to embedding vector can be done parallelly for different rows. It is not required that sequentially row by row it needs to compute. Okay, and it is embarrassingly parallel process. So basically there is a term called embarrassingly parallel, which is nothing but in parallel computing, an embarrassing parallel workload or problem is one where little or no effort is needed to split the problem into number of parallel tasks. And here I hope you can clearly understand that for one particular text, converting to vector is completely independent for another particular text converting to vector. So it is nothing but falling under embarrassingly parallel process category. We can easily convert this text into embedding vectors in parallel manner using Pandarallel. Okay, so that's why here we are importing Pandarallel, and we are starting 8 worker nodes, and parallelly it will apply this generate embedding function on the text column, because here if you see in the text column our news informations are available, and it is going to create a new column called text embedding, right? So here we can start the process, and here we will be seeing 8 workers has started, and it is showing its progress as well. By that time, let us go back to our RDS, and here you will see the status is available. So here we have got the endpoint or post, and I'll be using SQL workbench to log in this Postgre RDS. Okay, so here I am having my SQL workbench, and I can open the application. And here PostgreSQL is already selected. I need to change the host name. Okay, right? And the database name here also you need to change if you are using some other database. Here I have given the database name as test-kaggle, so it is same. And password we need to also provide. So here I'll be giving the password what I have already configured by launching the database, and here I can click on OK, right? So here it is connecting to the database. Let's wait for a few seconds. And database connection is complete. I can expand this, and I need to create some tables and install the extension for pgvector and all. So first, as a first step, what we are doing, create extension vector, and then we are checking whether vector data type is available in our pgvector or not. So here it is created. and if I execute select type name where type name equal to vector, here we are getting the result. I'll commit this operation because these particular things should be available throughout our whole process. And here I am creating a very simple table, BBC News, where first column is article ID, next is text, next is its category because we are storing the training data set. We are already having the category with us, and the embedding vector. Okay, now here the vector representation when we are storing, we are configuring 384 because here this particular model will basically return us 384 dimensional vector, right? Here you can see vector conversion is keep on going. So till then I'll be creating this particular table. Okay, and here if I do select start from BBC News as of now, here you will see it is empty. I'll commit this particular step, so that way this particular table will be accessible from our Google Colab notebook also, and that way we can execute insert into command to insert the embedding and all other information in this particular table. Okay, right? So here it is running, let it run, and once it will be executed, we will execute df.head to check whether we are getting the embedding representation of it or not. And then another step we need to perform. Here we have seen already that this particular function basically return us an numpy array, right? But when we will be storing the dataset, it is better to convert that to a list. So that's why we are using .apply to convert that particular numpy arrays to a list in the text embedding column in our data frame. Okay, and then as part of the next step, we are iterating in our data frame. For each row, we are executing insert into BBC News. In this particular table, we are storing article ID, text, category, and text embedding, and the values we are taking, whatever we are getting as part of df.iter rows, that one we are extracting and we are storing in our BBC News table, right? So that way, all the embedding vectors along with article ID, text, and the category or the classes will be ingested in this table, and then we can use that particular table as vector database to classify any unknown text to a particular category, right? So we'll be doing that one also. Let's wait for a few seconds, and here you can see few steps are already completed, and now all steps are completed. Now if I do df.head, here we'll be getting the text embedding column as a new one along with all other existing columns. Okay, now we'll convert that particular column from numpy array to list, and here we'll be executing insert into command to insert this whole data frame in our PostgreSQL vector database or pgvector. Okay, right? And here I am not doing this particular step parallelly because obviously our database connection is having the upper limit that at a particular time this many connection can parallelly be open. So to avoid those kind of issues, here I am doing this in sequential manner. Okay, so here we have got some error, dbcon is not defined. Okay, so we need to define this db connection. Host name I need to take from here and update here. I'll be executing this command, and then here I'll be creating the db connection. It is done, and then here I'll be executing this code again. Okay, right? So here the code is getting executed, and eventually data will be inserted in this table. And point to be noted, I am not using any explicit commit because while creating the connection using PostgreSQL wrapper, here itself we have defined that auto commit, right? So automatically the data will be committed. So here it is getting executed, and here if you see one more interesting part, that here df.iter rows we are basically using to iterate in the data frame rows, right? So only in the dictionary format we will be getting in the second variable. The first variable basically returns the index position for that row, and we actually don't need that index position. And whenever a function returns some values, and if you don't need any particular information, instead of naming it, you can basically just put this kind of underscore. Okay, so this is a good practice in Python. So that one I have followed because I don't need that index positions basically. And here this row is executed. Now if I execute, see, let's start from BBC News, maybe limit 10. And here if I execute, here you can see along with article ID, text, categories, and here we are having the text embedding columns also stored. Okay, now we can perform cosine similarity between our test vector and this stored vector, and we can find out which vector is having highest similarity. For that, whatever category is available, we can map that same category for that unknown test vector as well. Okay, right? So now we will be reading our testing data set, and we'll be executing .head to view the dataset once, where we are having only article ID and text or news information, but we are not having the category or the class for the same, because that one we have to determine. Now here we are generating the vector representation using parallel processing again for this test dataset as well, and once that is done, we will convert that numpy array to the list. And here this part is optional, I can delete that. Okay, let it get executed, and then I'll be explaining you the further steps. So here embedding for our testing data is complete. We can convert that to list. We are inputting numpy as NP. It is not needed as of now. And now we need to find out for this test data embedding vectors, what are the cosine similarity in our training data set or in our PostgreSQL data, which vector is having highest similarity, right? Now how to find out that? For that, just a quick recap on the theoretical part. That suppose we are having a vector like this, A vector, and this is suppose training vector, and we are having another vector B vector, suppose this is test vector. Now as you can see, the angle between them is very less, and you also recall the cos theta graph, which basically oscillates between -1 and 1, when it is 90 degree, when it is 180 degree, right, and when it is maybe 270 degree, right, this kind of values you can plot. So when theta is 0, it takes value 1, then at 90 degree it is 0, then at 180 degree it takes -1, then at 270 degree it takes the value again 0, right? So here if you see cos theta equal to 1 when theta equal to 0, that means when the vectors are highly similar, that time cos theta value is 1. And how we compute cosine distance? It is 1 minus cos theta. So that time cosine distance is 1 minus 1, it is 0. So when the vectors are highly similar, that means there is no angle between them, they are overlapping. In that case, cosine angle is 0. And when the vectors are highly dissimilar, in which case they will be highly dissimilar? For example, here we are having A vector, and in the complete opposite direction we are having B vector. The angle between them is 180 degree, right? So in that case, if you check the cos theta value, it is -1, right? So 1 minus -1 equal to 2. So in that case, the cosine distance is 2, right? So I can say if cosine distance, that is 1 minus cos theta value, is high, that means the vectors are dissimilar, and if the 1 minus cos theta or that cosine distance value is less, that means the vectors are similar. So basically, in short, it is having a reverse relationship. Cosine distance high, that means similarity low, and if cosine distance is low, that means similarity is high. You just remember this particular point, because this will help us in deriving the SQL code. Okay, right? So here what I will do, I will maybe clear all this, and then I'll be going to our SQL, and I will show you the demo how to find out highest similar item from our training data set, right? So cd start from, here we can take the table name, and let's consider a vector from our training data set itself. So here I'll be copying this complete data, and here I'll be pasting that. Okay, right? So for this particular vector, which vector is most similar, that one I need to find out from this training data set. So for that, as I told you, that to compute the cosine distance, we need to write like this way. With what column we want to compute cosine distance? That is text embedding. Text embedding, and to compute cosine distance, this is the way. And we need to make sure we are putting this another vector within string. This like this way. Okay, right? And then, as I told you, that cosine distance lower, that means similarity higher, right? So I can do a simple order by ascending order for this particular value, because this value will give me the cosine distance between each available vector and this training data set, and we need to find out for which data the cosine distance is minimum, right? That means they are most similar vector. So we can do a simple order by based on ascending order, and if we don't mention anything, by default it does in ascending order, right? So that we will be doing, and the top one similar item we need to pick up, right? So limit 1 I can do. Okay, so because in this case the training data itself I have picked up, that is for the article ID 1833. Here, if this query gives us 1833, this particular row, that means we can understand that this is the correct code for similarity detection. And if I run, here we are getting some error. Let's see. text embedding does not exist. Okay, actually it is text embeddings. Okay, I'll execute this again. So here if I execute, you can see that we are getting article ID 1833, right? So in short, you can understand like this way. This query can give us the most similar vector available in our PostgreSQL database. The same thing I have done here basically. Just copy this particular vector from here and I can put that here. This vector, and then limit 1 we are computing and fetch all the rows, and out of that the 0th element we are extracting, because by default if you see it will be returning like this way, result equals to. So I can execute this, and here if I just print the result, here we will be getting first array, and within that we are getting a tuple. So that's why first element of the array is 0 and first element of the tuple is 0. Like this way I am executing. So now if I execute the query directly, I will be getting the business as output, because for this particular text news the category is business, right? So we are getting it. So now we can put this particular thing within a function, and that is def similarity search text. We can pass that as function argument, and we need to extract only the category, right? Because we are only interested in the category for that news. Okay, and limit 1, and we are doing order by and computing the cosine distance with all available data, and then we are sorting in ascending order, and we are taking top element which is having minimum cosine distance or highest similarity, and then we are taking 0 of 0 because array and tuple is there. So like this way we have created a function. Okay, now here we have already done test embedding. If you see our df testing data dot get, here we are already having text embedding. For each row we need to call this particular similarity search function, so that we are doing using simple applet. Okay, so I will run this one, and the classifier will try to give us the category of that most similar training data. So it is going to take some time, because I hope you can understand for each row this query will be executed. Okay, and the vector what it will be taking from text embedding column, right? And once that is done, we will be executing dot head to check whether classifier column is created or not for our testing data set, and then it is created. And if you check our output format for our Kaggle submission, here if you check this one, here it should have only article ID and category. So that's why here what I have done, I am taking the article ID and classifier column, and I am renaming classifier as category, because that is what our Kaggle is expecting. And here if I do output.head, here we are having this kind of data, article ID, category, same format in which Kaggle is expecting, and we can write the data in our this particular local Google Colab file system, and we can download this one, and then we are good to upload our submission. So here we can browse the file and pick up this particular output file, open this one, and here it is uploaded, and I can click on submit. Once submitted, it will give me the score, that how much correct output we have. Okay, and here if you see, the score is 0.97. Obviously the highest score is possible is 1. So out of that 0.97, that is 97% correct output we are getting if we are doing classification in this, which is pretty much good, right? So this is how, using PostgreSQL pgvector, we can perform text classification for any natural language processing use cases. All the codes and the reference links I will be providing in the description box. Please go through those and try to implement by your own as well, so that way you will be understanding this concept in a better way. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.